Bill and Jack, two of our carburetor experts, are going to help out the service manager in a session on 68 model carburetors. They're ready to start, so we'd better move in to see what's on the program.
And we can each take turns talking about these carburetors to point out the changes. But I think I'd better start with the things that apply to all the 68s.
Okay, start the show.
Well, they're using only the Chrysler Ball & Ball, Carter, and HOLLEY carburetors on the new model cars. And with a cleaner air system standard in all U.S. models, there are no special identification tags to watch for. Also, with a cleaner air system, the distributor vacuum advance control valve isn't used on automatic transmission cars, except for the 426 Hemi models. Because manual transmission cars have different operating characteristics, they need vacuum control valves to keep exhaust emission within legal limits. In addition to vacuum valves, throttle valve dash pots are also used on the carburetors of all cars with manual transmissions, with the exception of the Ball & Ball BBD two-barrel model on the 383 cubic inch standard cam V8.
Why are there dash pots only on the manuals?
The dash pot keeps the throttle from closing too soon, so it reduces exhaust emissions when you're slowing down or coasting in gear. If the throttle snaps shut when the driveline's turning the engine above idle speed, there's not enough mixture coming into the manifold to produce good combustion.
Thanks, Tech. Now, one more thing. Choke and vacuum kick calibration has changed for some models, so a spec check is in order. But just remember, with a cleaner air system, all adjustments are more important than ever before. And now we're ready for the individual carburetors. It's all yours, Jack.
Okay, let's start with the Ball & Ball BBS single-barrel carburetor used on the 170 cubic inch slant 6. First of all, the venturi diameter in the automatic transmission carburetor is larger than in the manual model, so they're not interchangeable. Now, these carburetors are made about the same as the 67s, except for the idle systems. The idle system change limits the adjustment range, so the mixture will stay within government limits for exhaust emissions. Here's what's different. The idle mixture adjustment range for each BBS carburetor is determined by a precise flow test at the carburetor factory. When the rich idle mixture limit is reached, a stop screw is installed in contact with the idle mixture screw and sealed. This screw stops further movement of the mixture screw in the rich direction during service adjustments.
The idle mixture screw is made of soft material and is not intended to be removed for cleaning or any other reason. If you force the mixture screw beyond the sealed stop screw, it'll break off in the hole and you'll have to replace the entire throttle body. Now, what's next?
The HOLLEY 1920 series single-barrel carburetor, Tech. It's used on the 225 cubic inch 6, and here again, the automatic and manual transmission models are not interchangeable. The idle mixture screw is unchanged and can be removed. However, inside the carburetor, a precisely calibrated flow limiter is used in the idle fuel passage. This limiter determines maximum fuel flow in the idle system, so you can't get an over-rich mixture no matter where you set the idle mixture screw. Now over to you and the Ball & Ball BBD, Bill.
Limited adjustment idle mixture screws are used on the Ball & Ball BBD 1 1/4 inch two-barrel carburetor for the 273 and 318 cubic inch V8s. Here, as in the BBS model, the mixture screws are not removable and should not be forced against the stops. The accelerating pump lever on this carburetor now has an elongated pivot hole to let you floorboard the gas pedal abruptly without overloading the accelerating pump linkage. The pump lever remains at the top of the slot during normal operation. However, the plunger end of the pump lever becomes a pivot point when the throttle is opened suddenly. This allows the lever to move upward at the elongated hole and relieves the load on the plunger. Now it's back to you, Jack.
Right, and here's the brand new Carter AVS 4-barrel carburetor used on the 340, 383, and 440 cubic inch high-performance V8s. Primary bores and venturis in the 440 model are larger than the others, but secondary bores are the same size in all AVS models. AVS stands for Air Valve Secondaries, and the name tells you part of the story. The new air valve looks like a choke valve, but it's actually used to control fuel flow at the discharge nozzles in the secondary bores. When you push the spring-loaded air valve open, you'll notice there are no venturis or velocity valves in the secondary section, just straight bores, fuel discharge nozzles, and throttle valves. Here's how the air valve does its job. When the secondary throttle valves are closed, there's no airflow through the bores, so the spring holds the valve closed. Spring tension on the valve is fairly light, so it starts to open practically at the same time as the throttle valves. However, the spring tension causes the air valve to lag slightly when opening. This produces a pressure drop which starts fuel delivery from the discharge nozzles. The light spring tension allows relatively small airflow to open the air valve completely. Now, when you floorboard the gas pedal at low speed, the throttle valves open wide and manifold vacuum drops momentarily. But even though the incoming air velocity is low, fuel flow starts almost immediately, preventing an acceleration flat spot. Air valve spring tension is adjusted by turning the spring retainer as described in the service manual. However, the valve and spring seldom give trouble, so there's usually no need to change the spring adjustment.
What happens if the spring setting's off?
An incorrect air valve setting can cause a momentary rich condition at low speed with a wide-open throttle if spring tension is too high, or a lean condition if tension's too low. But as I just mentioned, spring adjustments seldom needed.
What's the story on the ABS idling system?
It's completely new and different. Now there's only one idle mixture screw instead of two. It's still called the idle mixture adjusting screw, but here it varies the idle air bleed instead of idle fuel flow. Idle fuel flow is controlled by adjusting screws as before, but now we call them idle mixture limiters. These limiters are carefully adjusted and balanced at the carburetor factory and are not intended for service adjustment.
The idle mixture limiters are adjusted on high-precision flow meters under laboratory conditions. These settings cannot be duplicated with less accurate equipment, and there's no need to disturb the seals or remove the limiters for cleaning. The best servicing practice to use on all sealed adjustments is hands-off.
This single adjusting screw arrangement makes idle adjustment a lot simpler and quicker. You don't have to spend a lot of time adjusting and readjusting two idle mixture screws and the speed setting to get the right mixture and balance.
Correct mixture balance is needed for more than good idling. It's the only way you can get your jobs to pass government specs for exhaust emission. All you adjust here is idle speed and the single mixture screw. Idle balancing's already done for you. Now you'd better tell us how the idle system works.
Okay, Tech. The general layout of the idling system's nearly the same as before. But here, we change the mixture by varying part of the idle air bleed with the single adjusting screw. Maximum richness is controlled by the mixture limiters, which are set and sealed at the factory. The new mixture screw has a left-hand thread, so the effects of adjustment are the same as with conventional mixture screws. Here, when you turn the screw clockwise, it still leans out the mixture, even though the screw moves outward instead of in. You'll also notice this screw has finer threads than the idle mixture screws you're used to. This makes it easier to get the precise setting needed to put the mixture within exhaust emission spec limits. Now, besides the mixture adjusting screw, there's also a new check valve controlled passage which adds extra air to lean out the off-idle mixture for better emission control. The passage restrictor is preset and sealed at the factory and needs no servicing. Now, on the bottom of the throttle body, you'll see two new bypass passages which replace the air holes previously used in the primary throttle valves. Like throttle holes, these passages help to make the idle and transfer positions of the valves less critical. However, with the new passages, the bypass air comes in through the sides of the bores directly under the idle mixture ports. This gives better idle mixture distribution because it diffuses the mixture, which tends to remain on the throttle bore walls under certain conditions. Now, back on the outside, you can see that the choke unloader cam now has a contact arm for better operation. The unloader adjustment is the same as before. The rest of the AVS carburetor is practically the same as the AFB model you've already worked on.
Okay, Jack, take time out. Right now, it's time for someone to work on the record and turn it over so Bill can tell us more about carburetors for 68.
Since Jack's got us going in the 4-barrel department, I'll take on the HOLLEY carburetor used on the 440 cubic inch standard camshaft V8. Like the AVS, the HOLLEY 4160 series 4-barrel carburetor also has a single mixture adjusting screw with a left-hand thread and sealed idle limiters. However, in this carburetor, the mixture screw is located inside the air horn. Now, from the bottom of the throttle body, you can see that the idle and transfer discharge ports are on opposite sides of the primary bores. This arrangement is used because the primary idle and the transfer systems are separated to provide closer control of the mixture ratio. Here's how the new system works. At curb idle, the idle discharge ports are fully open below the throttle valves. The transfer port slots are only partly open below the throttle valves, so their discharge is relatively small. With the throttle valves closed, most of the bleed air for primary idle mixture flows in past the mixture adjusting screw. It mixes with idle fuel, which is metered by the idle mixture limiters. The mixture then flows through separate passages to the idle discharge ports. When the throttle valves open slightly, the transfer port slots are completely open to manifold vacuum, and the separate transfer mixture system goes into full operation. Air from the inlet bleed openings above the primary venturies mixes with fuel from the transfer metering tubes. Then the mixture discharges from the transfer slots. Now, in the secondary bores, the idle ports and transfer slots are positioned on the same side as in the 67 HOLLEY carburetor. As before, there's no mixture adjustment for the secondary idle system, so servicing procedure is the same as before. However, there's no secondary throttle stop screw in this carburetor. The threaded screw hole is still here in the throttle body, but the adjusting screw is not needed with current model throttle valves. The rest of this HOLLEY carburetor is just about the same as the 67 model. Of course, you'll have to check all the settings and adjustments with the latest specs in the service manuals. So it's your turn again, Jack.
And that brings us to the Ball & Ball BBD 1.5-inch 2-barrel carburetor used on the 383 cubic inch V8 engine. At first glance, this carburetor appears the same as the 67 model, but when you look closer, there's a new mixture adjusting screw on the throttle bore side. On the fuel bowl side, sealed mixture limiters replace the conventional mixture adjusting screws. The idle mixture screw has a left-hand thread, and the idle mixture limiters are preset like those used in the Carter AVS 4-barrel carburetor. Here again, the mixture limiters are sealed in for keeps, and there's no need to disturb them for any reason. Also, like the AVS model, this carburetor has a new off-idle air bleed passage which is controlled by a factory-sealed check valve. The check valve opens automatically to admit extra air when a leaner mixture is needed. On the bottom of the throttle body, there are two bypass passages which replace the previous throttle valve air holes. As in the AVS carburetor, these passages provide better idle mixture diffusion and distribution. The rest of this carburetor is the same as the 67 model.
And that brings us to the 426 Hemi V8. Ready, Bill?
Ready, Tech. The changes are in the idle systems of the dual Carter AFB 4-barrel carburetors installed on the Hemi engine. The rear carburetor idle system has changed the most, so I'll talk about it first. The rear carburetor now has primary and secondary idle systems to improve idle mixture distribution. Only the primary section has adjustable idle mixture screws. However, both systems feed in the usual manner. The primary idle system has limited travel type mixture adjustment screws. As in the Ball & Ball BBS single-barrel model, factory-sealed stop screws prevent removal of the mixture screws. Now, in the front carburetor, only the primary section has an idle system. But there are no mixture adjusting screws because the mixture ratio of this system is fixed, like in the secondary section of the rear carburetor.
Okay, so much for carburetor changes. Now, how about a review of idle adjustment procedures?
Okay, Tech, first I'd like to point out that the total amount of adjustment is limited no matter which idle adjustment arrangement is used. This means you'll have to make sure that all other engine, ignition, and carburetor adjustments are correct, or you may not be able to get a good idle within mixture adjustment limits.
Don't expect idle mixture adjustment to make up for poor compression or sloppy settings elsewhere. And whatever you do, don't try to force a limited travel mixture screw beyond its stop. The screw will shear off and you'll have a useless throttle body on your hands.
Good point, Tech. Now, on the ball and ball models, you'll notice the reduced head diameter of the limited travel idle screws. Screw material is now aluminum, which is softer than the brass previously used. The middle diameter of the screw between the thread and the taper is necked down to clear the sealed stop screw which limits mixture screw travel. Since each stop screw is properly set at the carburetor factory, there's no need for service adjustment. Follow the specs in the service manual or on the engine compartment decal for idle speed and the mixture screw setting. You can save time in the final adjustment by turning the mixture screw in the lean direction, because the combustion analyzer reacts faster moving from rich to lean. Next, on the HOLLEY single-barrel carburetor, the idle mixture screw is still turned counterclockwise for a richer mixture. However, the new mixture limiter in the idle fuel passage keeps the mixture from becoming too rich. In other words, the adjusting screw can only make the mixture leaner than the maximum rich limit. Here again, idle speed and mixture settings must meet the specs, and the final adjustment should be in the lean direction. Finally, the remaining 2- and 4-barrel carburetors with the single mixture adjusting screw and preset idle mixture limiters are all adjusted in the same general manner. As you already know, these mixture adjusting screws have a left-hand thread. You see, when you vary the idle air bleed, the effects are just the reverse of varying the fuel flow. For example, when you move the new type mixture screw outward, it admits more air and makes the mixture leaner. And, of course, when the mixture screw moves inward, less air is admitted and the mixture turns rich. So by using a screw with a left-hand thread, we keep the conventional clockwise for lean and counterclockwise for rich rotation you're familiar with. The new single idle mixture screw makes the whole job a lot easier. Instead of working back and forth between 2 mixture screws for a balanced mixture and good idle, you simply adjust the single air bleed screw. Of course, you still have to reset idle speed as needed.
In effect, controlling the air bleed gives you a fine vernier adjustment to help you get a good idle with exhaust emission within legal limits. Local emission regulations are in the works across the country, so you may as well get used to tighter settings and adjustments all along the line.
Right you are, Tech. Now, for our wrap-up, here are a few things to keep in mind when you check or adjust the distributor vacuum advance control valve on cars equipped with manual transmissions. As you probably know, you first back off the adjustment on the throttle valve dash pot. This is done to prevent the dash pot from interfering with throttle closing when you check the distributor vacuum valve. During the test, when you open and release the throttle to test operation and adjustment of the vacuum valve, distributor vacuum should drop the specified amount within 3 seconds after the throttle is released. However, where the vacuum valve adjustment is turned too far counterclockwise, the spring may not be able to return the valve to idle position and distributor vacuum will remain high. If this happens, ignition timing remains in the advanced position and causes the engine to run at higher than normal idle speed, even though the throttle is closed. The effect is the same as dash pot interference, but in this case, the dash pot's not guilty.
And that's our final service story for this session. You can see there's nothing really complicated about these carburetors, so servicing them should be a breeze for you master technicians out there. The most important thing to keep in mind is the need to keep compression and ignition as well as carburation and proper adjustment, so you'll be able to hold exhaust emission at an acceptable level. Be sure to check the service manual coverage on these carburetors. And as always, you'll find additional information in your reference book for this session. See you all at the next session.